Hello. Today let's derive the derivative of the square root function d by dx of the square root of x, that's equal to 1 over 2 root x. Okay, so we have our usual formula. F prime of x is equal to limit h approaches 0, f of x plus h minus f of x over h is equal to, our f of x is the square root function, so f of x plus h is equal to the square root of x plus h minus square root of x division h and limit h approaches 0. Okay, multiply this radical with its conjugate, so limit h approaches 0, the square root of x plus h minus square root of x multiplied with the conjugate radical square root of x plus h plus square root of x over h multiplied with the same square root of x plus h plus the square root of x. The numerator becomes limit h approaches 0. The numerator becomes the product of the conjugate radicals, the square root of x plus h minus square root of x times the square root of x plus h plus square root of x. We can use the a squared minus b squared formula as a minus b times a plus b. So this is equal to a squared minus b squared. So a squared is x plus h, square root of x plus h squared, that becomes x plus h minus the b squared, that is the square root of x squared. Yeah, let me write this as square root of x plus h squared for more clarity. Yes, square over h times the square root of x plus h plus the square root of x. Okay, now the numerator becomes limit h approaches 0, x plus h minus x over h times the square root of x plus h plus the square root of x. Okay, the x and minus x cancels, limit h approaches 0, h over h times the square root of x plus h plus the square root of x, h cancels, limit h approaches 0, 1 over the square root of x plus h square root of x. Using limit laws, we can plug the h is equal to 0 into this expression and drop this limit symbol. 1 over square root of x plus 0 plus the square root of x, this is equal to 1 over the square root of x plus square root of x is 2 square root of x. Therefore the derivative of the square root function is equal to 1 over 2 times the square root of x. Okay, thank you.